All right, what's going on, everybody? How's it going? And we're live, guys. Welcome into another live stream. This is Dr. Drew coming at you. Today's Wednesday, November 12th. How you doing? So we're just getting started for today. Juan, welcome in. Good to see you. Guys, let's get the poll active. We're just gonna do a short poll today. Juan, how's it going? How's Ocam doing, buddy? Let's get 10 minutes on the clock today. Let's do 15 minutes. Let's do 15 minutes on the clock today. What topic should we focus on today? So as usual, the first 5 minutes, I'm just going to talk to people, chime in, see how we're doing. Hey. Have an exam tomorrow? What's your exam on? Shall we get started right away? Okay, poll is active. What topic should we work on today? Make sure you vote in the top left-hand side. Okay, what's y'all exams on? Jonah and Juan. Shall we just jump right into it today? We literally just started about 45 seconds ago. Okay. So guys, let me get my notes out here, but make sure you vote on the top left-hand side of the screen, chat. Vote on the top left-hand side of the screen. Is it going to be physics or organic chemistry? Let's hide this and then bring up this. Okay. So guys, here's that. And alkyne and alkene reactions. Alkene and alkene addition reactions with ether Z. Let's jump into it, Juan. Let's jump right in. Let's do it. You ready to lock in? You want to lock in for the session today, Juan? Let's do some addition reactions and synthesis. So which ones are hard for you? Bro? Are you comfortable with all the addition reactions? Maybe not all of them, but like which ones are going to be the hardest ones for you? Okay. So let's go ahead and do the first main addition reactions. It's going to be what and what? Let me pull this up. Synthesis. Okay, let's do some synthesis, buddy. So first of all, let me pull this up here. I'm going to drop this into the Discord. You need this. Okay, you need this. Make sure you have this. I'm going to pull this up. Hey Miranda, welcome in. Guys, we have the poll active currently. So we're going to start off today with synthesis. Oh, I think I already sent you this, right? I think I already sent you this. So let me just bring it up again. I'm going to drop this in Discord. I think we're going to lock in for organic chem today, guys. How's that sound? We haven't done it in a while. And guys, let's go ahead and bring this down here. And if I can take a screenshot of this. Okay, so Juan, I already know you're in the Discord, buddy, so I'm going to drop this in and tag you. You're going to have to memorize this by tonight, okay? You're going to have to memorize this by tonight. So let's do some synthesis. Okay, just give me 1 sec as I pull up my Discord here and then tag you. All right, Discord's opening. And then we'll open up this. Pull up the Discord. Into the hashtag chemistry. And go right here. Okay, give me 1 sec. So I got a reference sheet, so you're lucky. Okay, that's really good. Cool. So make sure you add this to your reference sheet. I'm gonna tag you. Okay. So here's that. Okay, I'm pretty sure that's you. All right, I just tagged you, so make sure you download this. Okay. So here's all of them. Okay, so here's all of them. Let's go through each of them one by one here. Okay. So we have an alkene. Okay. We have an alkene here. And okay, let's make this bigger. Right. So guys, we have the alkene reactions like this. And guys, don't forget to vote up in the poll up on the top left hand side of your screen. You have 10 minutes left. Okay. And all right, let's go through these one by one. So let's go through these one by one. We have basically our First one is hydrohalogenation. Okay, so let's go through these one by one. So the first one, right, is hydrohalogenation. That's going to be via Markovnikov addition. So first question for you, do you understand the difference between Markovnikov and anti-Markovnikov? Let me know. Okay, let me know if you understand the difference between Markovnikov and anti-Markovnikov. So which one's the first one here? So for example, okay, so for example, let's say I give you this one here is going to be okay, so let's say I give you this this molecule over here. Okay, example on hydrohalogenation. Okay, is going to be like this line and like this, and we're going to go up just like that. Here's our alkene bond, and let's say I gave you, for instance, HBr. Okay, so your job is to predict the product for HBr. Can you do this one? This is a good starter example. See if you can do that one here. So chat or Juan, what's gonna be the final product? I need help at understanding more. Okay. Hey Christelle, we're doing alkene addition reactions. All right. So guys, make sure you vote up on the poll on the top left-hand side of the screen if you haven't already. What topic shall we focus on today? We're starting off right off the bat with hydrohalogenation here. And we're doing HBr, hydrohalogenation with our alkene. What is that going to be? There you go. Okay, there you go. So we're going to basically take our HBr. Okay, we're going to take our HBr and let's do one quick mechanism just to see what's going on here. Our alkene is going to attack this proton here on the side. Okay, our alkene is going to attack this proton on the side. Let's do it down over here, chat. So our alkene is going to attack this proton here down on the side. We're going to attack over here and then move this double bond just like that. So we're going to create 1, 2, 3, 4. Now, the problem is we have a Br here, but we have a carbocation that lives right here. So we need to do one more thing to bring that up to speed. And that's going to be, well, now we generated our Br here. Okay, or now we generated basically an H is placed in the vanillic position. Okay, very good. The double bond will proton out the H and the Br. Okay, why does the alkene attack the proton? So the alkene acts as essentially a nucleophile. So alkene is highly nucleophilic. Okay, so we're gonna do a nucleophilic attack. Really good question there. So we're gonna do a nucleophilic attack because the alkene is highly, let's say, hungry for protons. Okay, and then we're gonna generate a carbocation intermediate. Now, this is gonna be Markovnikov addition. Now, with Markovnikov addition, then our bromine here is going to be minus here, and then come back and attack. Okay, excuse me. I meant to put, excuse me, guys. There was a big typo here. So I just put an H right here. Now our bromine is going to come in and attack over here. There we go. Okay, so that's how we generate our product via Markovnikov addition. So Markovnikov addition means we're going to go to the most substituted carbocation intermediate, but in this case it's going to be equal because they're both secondary. So guys, go ahead and let me know if you understand the difference between Markovnikov versus anti-Markovnikov. We're jumping right into it today. Lien, thank you for the follow. Does it matter what carbon since they're both secondary? In this case, it does not matter because they're both secondary. Okay, but if there are different number of constituents between carbons, there's gonna matter here. Guys, welcome to the chat. We're just getting started here today. So guys, we're gonna focus on alkene additions here. Okay, but make sure you still vote on the top left-hand side, just because I wanna see what folks are going through. So guys, we're gonna jump right into it today for organic chemistry. Okay, but make sure you vote on the top left-hand side if you want to see a different topic. Okay. So guys, we're gonna basically do some examples here for synthesis strategies. How's everyone doing today? We're just getting started for today. I'm gonna go on for 1 hour. Anyone that's new in the chat, welcome into the chat. My name is Dr. Drew. comment the word new if you're new. And if you've been here before, make sure you comment that lock emoji, guys, if you're about to lock in. Okay. And yeah, guys, so let's do one more example and then we'll fully introduce myself real quick. So guys, let's say I have this cyclohexene group here with an ene over here, and we're going to do synthesis here. So the question is, how do I go from A to B? So here's A. Oh, guys, let me hide this. Okay, welcome in, Elalian. Hopefully I'm saying that right. Eric, welcome in. Hold on, guys, let me hide this real quick. We're going to do another example here. Okay, so guys, we're going to go from A to B here. We have this cyclohexane, and we got to add this OH here. Guys, I go live every single week, Monday through Thursday, to answer your STEM questions. So drop any questions you have down below, whether it's for physics, gen chem, ochem, or math. Last time we did a lot of math, so today we're going to do some organic chem. So guys, how do we go from A to B here? We have basically this reaction on the left, and we have this product on the right here. Kathy, welcome in. This is chapter 9 in my textbook. I'm so lost because of all the reaction mechanisms in the book. Don't worry too much about the mechanisms, twin. Focus on just the easy mechanisms. Just focus on hydrohalogenation and focus on Markovnikov's versus anti-Markovnikov addition. Okay? You don't got to worry about the mechanisms as much. You need to worry about the reactions. So I literally just dropped the reactions in the Discord. If you want to join the Discord, it's 100% free chat. Okay, so guys, we need to use these reactions to go from A to B. Okay, Azenia is correct. We got to add sulfuric acid and water. And guys, we have 3 minutes left on the poll. Anyone that's new here, let me know if you're new here. Guys, let's get started. I'm going to reintroduce myself because we are just getting started here today. It's been 5 minutes already. And guys, welcome in to the chat. So once again, my name is Dr. Drew, and you're watching Engineering Minds. Once again, if you're new here, comment the word new so we can welcome you in. Okay, if you've never been to a live stream with Dr. Drew here, that is myself. Go ahead and comment the word new. And if you've been here before, comment that lock emoji because you know we are locked in today. Christelle, to join the Discord, just go into the link in bio and go into the website, engineeringminds.co. Click that link that says join Discord. Okay? This is going to be the best place for you to drop in questions, get free homework help, and meet other STEM members. Okay, guys, it's 100% free. And then join this here. Hi, Laura. Welcome in. Hi, Life. Welcome in. Welcome in, Peter. Okay, guys, so if you want to join the Discord, it's totally free. And guys, if you need tutoring, I got you for various STEM subjects. I got you for math, chem, physics. Okay. And once again, I go live every single week to answer your STEM questions. So in the Discord, I already dropped this. Okay. We're going to go over addition reactions today. So make sure you lock in if you have any questions about organic chemistry, addition reactions. Now's the perfect opportunity. So I already dropped this in the hashtag chemistry channel. So just join the Discord, go into the hashtag chemistry, and then here we go. Okay, because our buddy Juan asked about addition reactions, and here we go. So guys, we have this compound here. So based on these reactions, we have this alkene, okay, on the left-hand side, and then we have OH on the right-hand side. So which of these reactions do we got to use? What is the name of this reaction? How do we go from the left side is our compound A to the right side compound B? Let me make this a little bigger. So how do we go from this alkene on the left-hand side to this alcohol on the right-hand side? What is the name of that reaction? Well, notice that, for example, this one here, right? This one goes from an alkene to an alcohol, okay? So that is called acid catalyzed hydration. That is called acid catalyzed hydration, okay? So if we add acid, H3O plus, that's acid, right, chat? So H3O plus, acid. That's called acid catalyzed hydration. So that's how we go from A to B. But notice, what's another way of going from A to B? So notice that we can go from the alkene to the alcohol. So what's another way of going from A to B? Okay. So Kevin says SN1. Period. Welcome in. Good to see you. So Kevin says SN1, but what's another way of going from the alkene to the, yeah, there you go, oxymercuration, demercuration. So oxymercuration, demercuration is another mechanism. So you don't need to worry about oxymercuration, demercuration mechanism. I just want you to memorize that another way of going from A to B is adding HgOAc, that's mercuric acetate, okay, HgOAc2, in water and NaBH4. So the first step is called oxymercuration. Okay, that's an oxidation step, and then demercuration is a reduction step. Guys, I just recommend you memorize it. Don't waste your time trying to go through the mechanism for this one. It's a little bit too long. You're not going to be tested on it. Instead, focus on the reagents, okay? Because your exams are going to focus on the reagents, testing. Yes, you do need to understand the mechanisms, but in this case, your professors are going to test you on the reagents, right? At least for oxymercuration. For acid catalyzed hydration, yes, you do need to know that mechanism. Okay, guys, let me know if this is a good topic so far. If you're understanding and following along, go ahead and drop a thumbs up if you're understanding this so far. Okay, and if you're getting a little bit confused, go ahead and drop that crying emoji to let me know at what point you got cooked. Okay, you can find the reference sheet at the link in the description. Go to engineeringminds.co and join the Discord. I dropped that in the Discord, twin. So guys, if this is making sense, drop that thumbs up. There you go. Thank you, Eric. Laura says, yup. Fine Shine, welcome in, says, yup. Cool, guys. So who's ready for another example? So our topic today is alkene additions, but we can do any organic chemistry topic. Okay, so guys, here's another example. I'm going to give you another alkene here. I'm going to give you another alkene here. And I'm going to basically give you this cycloalkene. Now it's going to become a cycloalkane with, okay, now with a wedged alcohol here. Okay, with a wedged alcohol. Okay, so what does the wedge indicate, chat? Okay, if you couldn't join the Discord, something's wrong with your settings for your Chrome. So try again on Chrome or just DM me for the link and I'll send you the link, twin. Okay, chat. So we have this next example here. So what are the reagents we got to do here? What are the reagents we got to do here? And guys, let's get this together. So how mad is heat and mass transfer? I'm taking next semester. How bad is heat and mass transfer? How good are you with, okay, are you a chemical engineer? How good are you with math, chem, physics? Like personally, like that's one of my favorite subjects of all time. So I'm biased. I'm gonna say it's really fun. So if you like math and physics, you're gonna love math and heat transfer. But I'm really biased. Some people say it's like the hardest class ever, but I think it's like hard, but it's like fun. Okay, period says BH3THF NaOH. Swanee says words here. Oh no. Okay, Potato says doing my chem homework right now. No way. Okay, so hydroboration. Yeah, guys. So what's gonna be the next thing we gotta do? So guys, let's check what we have here. So we have our alkene. All right, we have our alkene, and then what do we have that's gonna be OH wedged versus dashed? Okay. So guys, look at this one here. This is our alkene here, right? This is our alkene, and our alkene is gonna be converted into. Take a look at this. This is gonna be an enantiomer with OH on this side. Okay, and notice that we have a methyl here as well here. Okay, so this methyl kind of went over here. So what if we did hydroboration oxidation? Okay, so I'm going to go ahead and do hydroboration oxidation. I'm going to add BH3THF. Guys, this is another really complex mechanism. It's too long to memorize, so don't even worry about memorizing the mechanism. Just memorize the reagents. BH3THF, that's hydroboration step. This is our first step. And then the second step is oxidation. So that's going to be H2O2 NaOH. H2O2 NaOH. You see what I mean, chat? So sometimes, yes, OChem is overwhelming because there's a lot to memorize, but once you do it once, we don't really have to do any work. It's kind of just like a memorizing game. So that's why OChem, that's how to make organic chemistry low-key fun, is to turn it into like a low-key game. We're turning it into like a little kind of puzzle, right? Would you guys agree that OChem is kind of like a little puzzle? So let me just go ahead and double check that this is the right answer here. This one is going to be, yeah, BH3THF. Okay, plus enantiomers. We're also going to get enantiomers. Okay, because we can also get the OH dashed here. Professor wanted you to know the BH3 mechanism. I forgot about OChem 2. It's my favorite class I've taken. I just got to do conversions with atmospheric and intermolecular forces. Sorry if I'm going too fast, Potato. There you go, Christelle. Welcome into the Discord. So you're gonna see me there. Feel free to introduce yourself, guys. If you want to join the Discord, um, let me know. You can join on the link in bio. Go to engineeringminds.co. Okay. So guys, you can join in on the link in bio. Okay. So Eric says you need to know the mechanisms too. Okay. So usually, okay, yes, you need to know the mechanisms, but usually for these three, for these two, hydration, oxymercuration, demercuration, and hydroboration oxidation, those are usually not required. Okay. Thank you, Jackson. Appreciate you. Guys, who's ready for another example? So let's do another example here. So this is going to be, okay. This is going to be, um, right over here. This is our alkene. And guys, remember, if you need tutoring for organic chemistry, math, or physics, I got you. Just shoot me a DM or sign up for tutoring at the link in bio. Guys, how's the semester going for everyone? What majors is everyone? Go ahead and comment down your major or year down below. Or if you're not in college yet, comment what major you want to do. Again, my major was chemical engineering. And guys, so here's our next example here. And look, take a look at this. Now we have a bromine, and now we have an alkane here. So, and now we have an alkene on the right-hand side. So what do we do down here? What do we do down here on this side? Notice we have elimination. Okay. Yeah, I got Lewis dot structures on my website, Twin, and my YouTube channel, Twin. Bio major, biology, biological sciences. Ooh, all the bio majors are here. I just failed my last exam. Oh no. I did not memorize the reagents. Semester isn't so bad. Pre-med. Chemi. Let's go, Chemi. Fellow chemical engineers. Eric says E2. Nelson got it. TBU okay. So Nelson, if you got TBU okay, how did you get that? How did you know it was TBU okay? So how do we go from a bromine here? Notice that we're going backwards this time. Where's the alkene this time? Always locate the alkene for elimination addition. So notice that we went from bromine here, okay, to an alkene. So that means we need what? That means we need to do an elimination reaction. Zoom out. How's that? Is mechanical engineering worth it? I think any engineering is worth it for sure. I think any engineering is for sure worth it. Okay, so you said Hoffman. So guys, we have to identify which one is this going to be. It's going to be basically our elimination reaction from a bromine here to alkene. So TBU, okay, is going to be a bulky base. Okay, everyone write that down. Everyone write down bulky base. And TBUK is going to be a bulky base. So that's how we convert our that's how we're going to convert our halide here, halogen, into an alkene. So this is the previous chapter. There you go. Bulky base favors elimination. Okay. There you go. Engineering is definitely worth it in the end. So we got lots of bio majors here. We got lots of engineers here. Guys, welcome in. Okay, guys, who's ready for the next example? Let me know if there's any questions here. So once again, I dropped all the reactions here in the Discord. So we're going through each of these one by one, or we're doing a ton of examples. Okay. Gracie says it looks for the beta hydrogen. Cool. Good, good. So let's do the next example here. And remember, guys, I go live every single week, Monday through Thursday, right around this time to answer your STEM questions. So today's topic is elimination and addition, but you're free to ask anything down in the chat or in the Discord. Okay, and again, if you want to join the Discord, it's 100% free. All right, guys, so now where's the alkene this time? So what do we do this time? So notice we have an alkene on this side. So always highlight the alkene. We have an alkene on this side, and then we have a bromine here. Okay, we have an alkene here on this side. So what do we need this time, chat? What do we need for our conversion here from an alkene? Well, if you memorize the table, then you're solid here. But let's say you didn't memorize it. Let's go ahead and go back to the table. Let's say you forgot. Okay, so I'm going to look for my alkene here, and I see which of these has bromine, and we're going to need any of them that has Br. So for instance, this one, but we don't have any enantiomers, or we don't have an alcohol either. So I'm going to go with reaction number 2. Okay, so reaction number 2 is going to be called hydrohalogenation. Hydrohalogenation, but we want anti-Markovnikov here. Okay, we got to see where it's going to be here. So what would happen? Let's do a side note here. What would happen if it's down here? So what is this called? So let's say I put a methyl group over here and then a bromine just like that. So what's the difference between the top one and the bottom one here? Can you do dehydration where you have OH as a leaving group? Sounds good. You can find the Discord at the link in bio. Go to my website, okay, engineeringminds.co. So all the information is up on the top. Tap the link in bio, engineeringminds.co. Click that link that says Discord. Okay, so what is a good way of getting a copy of this table? Guys, again, it's in the Discord. So let me just show that real quick. So guys, go to that link in bio. Go to engineeringminds.co. Okay, where you can either book tutoring or join this link that says Discord. Okay, so click join Discord and please, please, please introduce yourself, and make sure you're kind and respectful to other members. There's tons of other STEM members and engineers in there. Okay, and then you join in where it says hashtag chemistry. So this is where I dropped that table here, guys. It's hashtag chemistry channel. Okay, and please, please, please introduce yourself. So guys, what's the difference between the top and bottom? There we go. So the bottom is Markovnikov. So what does Markovnikov mean? So what is the bottom side? What does it mean if something is Markovnikov? So this one is going to be the Markovnikov product. Okay. And this one is going to be anti-Markovnikov. So what's the difference between Markovnikov and anti-Markovnikov? So can someone comment down below? What's the difference between Markovnikov and anti-Markovnikov? Okay. So with Markovnikov, we see that our first one was hydrohalogenation. We wanted, this one was going to be HBr. Okay. So if we had just HBr, we would have got our Markovnikov product. But it specifically said we don't want HBr. Okay. We don't want this. We want anti-Markovnikov. So we got to add what, chat? We got to add ROOR. Okay. Do you see why I'm going to add ROOR here? Because that's going to be our anti-Markovnikov, chat. Okay. So this is going to be HBr and ROOR. Guys, let me know if this is helpful. Drop some thumbs ups down below if this is making sense and this is actually helpful. And if you're confused, don't be afraid to drop that crying emoji or let me know if you have any questions. Okay, so if this is making sense, thumbs up. If you're confused, thumbs down, crying emoji. Halogen goes to more substituted, exactly. Peroxides. ROOR, how else can it be called? Good idea, good question. So what is ROOR going to be called? Eric, thank you for the thumbs up. So ROOR, well, that's basically going to be your R group connected to oxygen. So what should we call this? It's going to be basically our ester. It's going to be RO. Good question. What is that going to be called? Peroxides, you know? HOOH. That's another example. Okay. Okay. So is Markovnikov the same as Zaitsev? Ooh. So what's the difference between Zaitsev and Markovnikov, chat? So they have some similarities because they're both going to be looking at the total number of carbons. But Zaitsev is going to be more for elimination. Okay, Zaitsev is for elimination and Markovnikov is for addition. Right now we're not doing elimination, we're going backwards. Okay. Okay. There you go. Cool, cool, cool. So guys, who's ready for the next example here? And we're just going through these examples for elimination and oxidation. Elimination and addition. And remember, I am recording this, which I will be posting on my YouTube channel tonight. So if you miss any part of this or you want to rewatch it, just up to my YouTube channel, guys. It's the same as my TikTok. Okay. And so here we have this guy here. So another alkene going to another, okay, going to our another, this is going to be our alkene going to our alkane. And guys, does anyone have any exams on this? When are your exams coming up for organic chem? Or is it already passed? I'm already too late here. When do you guys have exams and finals? Okay, and if you guys have exams and finals, don't stress. Don't worry about it. Okay, you're going to be fine. All right, so where's our alkene this time? And what are we going to do this time here? Oh my gosh, next week? Just had it. Tomorrow. Good luck, everyone. Okay, so where's our alkene this time? What do we have this time? This is straight up what? There you go. Someone got it. Okay, this is just straight up a catalyst. So we're going to say H2, platinum catalyst. Okay, so whenever we want to get rid of an alkene, you want to add a catalyst. So that's going to be right over here. It's going to be called hydrohalogenation. Okay, so that's gonna be reaction number 5 right here. Okay, which again, you can always download this in the Discord link in bio. Okay, totally free. So that's gonna be hydrohalogenation here for our alkene to our catalyst. Okay. So yeah, guys, that's gonna be our next reaction. Let me know if there's any questions about this one. Oh, I gotta zoom in. I gotta zoom out. Does this count as MCAT studying? I think so. All right. November 20th, final exam over Mark, and December 10th. Okay. So guys, let's do the next example. And again, guys, if anyone needs any help, I got you on all these STEM subjects. I do math, chemistry, physics, and organic chemistry, and engineering. Okay, so guys, if anyone needs any tutoring, I got you for various STEM subjects. I can do physics, OChem, okay, calculus. Just sign up for a consultation call at the link in my bio, or just shoot me a DM with the word study to let me know that you're interested in tutoring. Okay, so guys, here's our next example. This one is our alkene here. So our alkene is basically living over here now. And what do we got to add this time, chat? What do we got to add this time for the Cl group to live here? Okay, what's gonna be the reactant here? Okay, so comment down below if you think you know this one. So again, this is gonna be a this is gonna be what? Do we need acid or what? There you go. Shrek got it. Welcome in, Shrek. Got my Orgo final tomorrow. Matt, good luck on your Orgo final. Everyone say W Matt. There you go. HCl. We're gonna add HCl. That's gonna be directly attacking that here. Okay, that's gonna be directly attacking HCl. How do you know what? How do you know what, Gracie? Hydrohalogenation. W Matt. Done studying for the day. Okay. So guys, let me know if there's any questions here. So this is gonna be just basically our HCl attack here. And guys, why don't we show the mechanism here? Because this one is the one we just covered. So I'm going to show the mechanism one more time. So we're going to use our alkene bond here. Okay, we're going to use our alkene bond and deprotonate that H here. And then guys, what's going to happen here? We're going to basically have our carbocation. Okay, so you'll have to memorize, chat, whether it's going to be on the Markovnikov or anti-Markovnikov here. So right now, is this going to be anti-Markovnikov or Markovnikov here? Okay. How do you know it's HCl, Gracie? Because we know it's HCl because this is going to be basically putting that Cl group. Notice that we have a Cl group over here. So if we don't have any Cl on the left-hand side, how are we going to get Cl on the right-hand side? Well, we got to add some form of chlorine, right? So we don't have any Cl on the left-hand side, so we need to add HCl here. And so what that's going to do is that's going to basically take our carbocation intermediate, and then guys, think of this as like a when you make it fun, it's more fun, you know. When you make it more interesting, OChem becomes fun. So I like to think of this as like a rizification here. The chlorine goes tries to like riz up the proton, the positive charge, okay, because it's a nucleophile. That's why it's called a nucleophilic attack. So it's like rizzing up. It's like rizzing up, literally. It's like rizzing up the carbocation. Okay? So when you start to make OChem fun like that, it starts to become more like understandable. That's how you start to like, you know, actually enjoy the subject. Okay? So think of nucleophilic attack as like a rizification step. Making sense? Guys, how are we feeling about these examples? Should we do a different topic or should we switch? So should we try different examples or more examples? So let me pull up a poll here. Can you talk about the D? This is also what replaces hydrogen. So it's a bit heavier than H. Yeah, D stands for deuterium. So D stands for deuterium. So deuterium is just heavy. That's just going to be heavy water. Okay. More examples on the addition or next topic. Guys, let's do a quick poll. So let's see how we're feeling. So I'm going to pull up a poll right now. So you got about 10 seconds to think about. Do we want to do more examples on addition reactions for organic chemistry? Or do we want to switch gears here to a new topic? And if you want to do some more examples on the same topic, you're saying, hey, we got some good momentum, don't switch it up. Make sure you vote happy face starting now. 60 seconds on the clock. So make sure you tap the top left-hand side of your screen that says the poll button. and let me know if you want to do the same topic, or if you're saying, you know what, I think I'm good, okay, then vote for crying emoji. Dang, we're getting 8, 9, 10 votes for the same topic, so we got to keep doing addition reactions, so don't kill the momentum. And guys, don't forget that I already dropped this in the Discord here, okay? So if you want to join the Discord, it's totally free. So join the link in bio. Let me show you how to do that. Go to the website. Okay, go to engineeringminds.co. Okay. And then click on that link that says Discord. Click join Discord. It's totally free. And then once you join, please introduce yourself. Let me know your name, major, where you're from, what you're studying, what classes you're taking. And then make sure you click on the hashtag chemistry channel. Okay. And then you can join that here. Okay, that's how you can download the sheet here. This is study guide. Okay. How to answer the poll, guys? You answer the poll by typing the top left hand side. So we're basically doing synthesis right now, twin. We got 10 votes to keep it going. So guys, let's do some more examples for synthesis. We're doing synthesis right now, twin. Okay. And guys, let me bring this down one more time. And let me bring this over here. And make this bigger. So guys, who's ready for the next example? Go ahead and drop that lock emoji to make sure you're locked in. And guys, if you're actually following along, don't be watching this on your bed. Okay, don't be scrolling on your bed. You're not going to retain any information by by watching TikToks on your bed. You have to actually follow along and take notes like an actual lecture. Okay, otherwise you're not going to retain any information, chat. Make sense? So guys, we're going to do this reaction next. And this is going to be a cyclopentene ring here. And this is going to be our 1, 2, 3, 4, 5 membered ring. And again, if you want to review this, I will be posting this on my YouTube channel later tonight. Okay, so you can rewatch the whole thing. Can you talk about oxidation reduction? So in the context of organic chemistry, oxidation reduction is going to be, for instance, oxymercuration, demercuration. So oxymercuration, demercuration is an example of a redox reaction in the context of organic chemistry. Remember, oxidation means we're going to lose electrons, and reduction means we're going to gain electrons. Remember in Gen Chem, the definition? So some of these are going to be oxidation reduction steps. Okay? So for example, oxymercuration, demercuration, this is a redox step. This is a redox process. Okay? And then this one is the opposite. This one's going to start with reduction, BH3TF. Hydroboration is a reduction, and then obviously oxidation is an oxidation step. So anytime we're adding a reductant, such as BH3, that's a reduction step. Anytime we're adding an oxidant, such as H2O2, that's an oxidation step. Okay, chat. So let me know if that clarified or if you need to explain anything more about redox. So here we go. How do we do this one here? How do we do this one? Shrek, how do we differentiate between SN1, SN2, E1, E2? So again, Shrek, make sure you join the Discord because I have a table that perfectly clarifies that exact question for you, twin. Okay, we went over that last week, so I don't know if I want to do that again, or I'll ask a bit later because we're on E2, we're on addition. Okay, but guys, if you want me to go over SN1, SN2, let me know. So guys, how do we go from here to here? How do we go from A to B? Okay. So here we have the alkene. Where's the alkene over here? So the alkene this time lives on what? This side, right? And then we have OH. So that's telling me we're probably going to need water or something like, some kind of oxidant. So what are we thinking, chat? We're probably going to do exactly what we just talked about. We're probably going to do that oxidation step. We're going to do the oxidant. We're going to do the reductant is BH3 THF. This is called hydroboration, and the second step is called oxidation. So this process is called hydroboration oxidation. So the first step is called hydroboration, and then the second step is called oxidation. So in total, we're gonna have the OH group is sourced from the peroxide, and then the alkene goes away from the hydroboration step. Okay, Very good, chat. So let me know if there's any questions there. Okay. So this is our next example here. And we got lots of votes to keep it going. So we're just going to keep it fresh. Keep it going. And yeah, again, guys, the best way to memorize these reactions is not by blindly watching a random dude's live stream on your bed, scrolling on your bed on TikTok. No, you're not going to retain any information like that. You have to actually log in and do the problems. Okay. Ooh, this one's tricky because we did an example really similar to this, but this time what happened? This time we're gonna have the alkene across like this. Ooh, okay. So be really careful with this one, chat. So what do we add this time? Okay. So how do we go from A to B? Okay. Can you show the mechanism? So twin, for hydroboration oxidation, it's really long. It's a really long-winded mechanism that I don't really want to show it because we don't really need to know it. Okay, because the first step in it of itself is like 1 page, and the second step is 2 pages. So in total, it's a 3-page mechanism. Okay, so guys, here's our next step here. What's gonna be our main reaction? Bed too comfy, bro. E1. So there we go. Now we have, yeah, there we go. Now we have another elimination. So, okay. Okay. So how do we know if this is gonna be? How do we know if this is gonna be? How do we know if this is gonna be E1 or E2? Okay. Can't see the full screen. Sorry about that, guys. Is this too big? There we go. Let's make it like that. There we go. So guys, is it gonna be E1 or E2? Okay. So if this is gonna be our if this is gonna be our if this is gonna be our E mechanism, we have to add what? We have to add some kind of base. We have to add some kind of base that's going to basically deprotonate. Okay, deprotonate that hydrogen, and then that's gonna be right over here, NaOET. Okay, this is gonna be our standard. This is gonna be our standard reactant here. Okay. Does oxidation mean adding an oxygen to the atom? Not necessarily. Remember, oxidation means you're going to lose electrons. You're going to reduce the oxidation number. Okay, oxidation means you're going to reduce the oxidation number of one of your constituent atoms. Okay, oxidation, oil rig. Oil means lose electrons. Reduction means gain electrons. Right? There you go, weak base. Guys, let me know if this one made sense here. This is just going to be NaOAT. Let me know when you're ready for the next example here. Okay, NaOAT. Let me know if there's any questions here about this one. And yeah, remember guys, you have to just keep practicing every single day. Why was it a weak base in this case? Because we want to have notice that this is going to be I like to draw like a little dot here at the edge of the alkene. Okay, so you can think of this as like a secondary versus secondary. So if we had, for instance, a strong base, then we would have a couple other options. We would have alkene next to the bromine. Okay, but we don't want that. Okay, we don't want that. So we want to avoid that. So we wanted to go with something a little bit weaker or a little more general, like sodium ethoxide, to go across the bond like this here. Okay, show the mechanism. All right, let's try it out. So for this mechanism, we're going to have NaOAT. So NaOAT, chat, is going to be what? Is NaOAT an acid or a base? Okay, so NaOAT is going to be essentially a salt. It's going to function as a base. It's going to break apart in equilibrium into its constituent Na+, and OET minus, right? Guys, and this is something I go over all the time with my clients. So again, if you need OChem tutoring, guys, I'm your guy. Okay, just shoot me a DM or sign up for tutoring, link in my bio. Okay, so if you're cooked for OChem, definitely hit me up. Okay, so here's our NaOAT, and we're gonna basically attack this proton. We're gonna attack this proton right over here. So this proton lives right over here, and the OET is going to be hungry, yum yum yum, yummy in my tummy. And we're actually gonna do this in two steps. We're gonna do SN1. We're gonna do E1. So first we're gonna do loss of leaving group. So step one is loss of leaving group. Okay. So step one is loss of leaving group. So I feel like the loss of leaving group is like the breakup. That's like the it's like the breakup. It's like, you know what? I'm tired of you. No, baby, don't leave. I'm sorry. I'm out. I'm out. I'm gonna head out. Okay? So that's our loss of leaving group step. And we have bromine is straight up gone. Okay? Now, that's gonna generate a carbocation intermediate that lives right over here. Okay? But don't worry because now we're gonna have a what's it called? A rebound relationship. So now the rebound, you versus the guy she told you not to worry about, our OET minus comes in for the kill. Our OET minus is gonna swoop that proton. Okay? And OET minus is going to boom attack that proton and generate that alkene bond. And that's how we generate our final product here. Okay? I only see a link for YouTube and Instagram. Gracie, can you tap that link that says engineeringminds.co? Do you see that? That says engineeringminds.co. Evelyn says sodium methoxide is not a weak base. Okay, so I said sodium methoxide is a weak base. It's relatively weak because it's not a strong base. Okay? So what if the BR was on a dash? What if the BR was on a dash? Well, right now it's tertiary, so I'm not 100% sure what that would be because it's already tertiary, so it wouldn't really change anything. So it wouldn't change anything. Okay? Babes, it's E2. Oh guys, hold on a sec. This is E2. Is this E1 or E2? Hold on guys, I'm getting cooked up for a sec. Hold on. Hold on a sec, guys. This is actually I'm actually getting cooked right now. Hold on. This is actually E2. This is gonna be E2. Then we got to do that in one. We got to do this concerted. I did E1. No, this is not only for chemistry, but you can ask me anything, whether it's chemistry or physics. Hold on, chat. I gotta lock in for a sec. Why is this E2 real quick? Hold on. Sorry, chat. Someone said this is E2, and now I'm starting to overthink a little bit. So let's try one more time. If this is concerted, then what we'll have is our OET is basically going to come in and deprotonate this right over here, concerted. Okay? And then bring that down just like that. Okay? But we're still gonna get the same final product. At the end of the day, the main question was, what do we need here? And the answer is still sodium methoxide. So we're still going to use sodium methoxide anyway. Okay? I just have to review if this is E1 or E2. So this one was E1, and then this one was E2, concerted. Sorry about that, chat. I'll make sure to check that. Okay? So, okay, Shrek is saying because it's a strong base. Yeah, okay, that makes sense. Yeah, that makes sense, because this is technically going to be an E2. Sorry about that, chat. Okay, so please erase this. Please erase this. Okay, this is not correct. My apologies, my friends. So this is actually E1. So I actually made a really common mistake here. I said that E1, E2 was E1. Okay, so that's because it's NaOET. Okay, Gracie still can't find the link, guys. Let me get my TikTok out real quick. Hold on, so you guys can see that. And guys, we're gonna keep it going. Let me know if you guys have any more questions for Math Chem Physics. Okay, so if you basically swipe right to my profile, right? Do you see that, twin? So this first link that says engineeringminds.co, that's the website. Okay, so you're gonna see that and then click on that. Okay, so this is the website. So this is where you can, again, either book tutoring or join the Discord. Okay, so join the Discord, you just fill that out, check your email. Okay, and then once you're in, then feel free to introduce yourself in the hashtag introductions. There you go. Okay, there you go. And then you can download this sheet there. Okay, of course. By the way, guys, let's go back to the E1, E2, because obviously your boy needs to review that. Let's go back to E1, E2, SN1, SN2. So I should have added another sheet here. Let me see if I can find it here. Here we go. So this one is for E1, E2, SN1, SN2. So let's review this one because I was getting cooked up in the last one. So remember, in the last one, we had NaOAT. Okay? In the last one, we had NaOAT. Let me make this bigger. And so NaOAT is going to be basically in our case 3 here. So to read this table, you have 3 cases. You have case 1, case 2, case 3. Okay, so for instance, case 1, you're going to have only a nucleophile. So for instance, halogens are going to act only as nucleophiles. So anything that is Br minus, Cl minus, I minus, that's going to be a nucleophile. Or for instance, SH. And then if you look at the substrate, and if it's primary, secondary, tertiary, that's going to tell you if it's going to be SN1 or SN2 dominant. So if it's primary, it's going to be SN2 dominant. If it's tertiary, it's going to be SN1 dominant here. Okay, so you can't see the explanation. What do you mean? Okay, and then base is going to be only E2. So base is going to actually be easier. So if something, for example, DBN, which functions only as a base, that's only going to be E2 dominant. So remember, E2 is your concerted elimination reaction. And then for a strong nucleophile or a strong base, that's going to be RO minus versus HO minus. And then now we have to determine if it's going to be primary is going to be SN2 major, secondary is going to be E2 major, or tertiary is going to be E2 major here. So try to memorize this, but don't try to memorize per se. Try to understand actually why. Okay, try to actually understand why this is the case. And then finally, for the weak nucleophile or weak base, for instance, ROH, okay, then if it's primary, it's going to be SN2 or E2. Or if it's secondary, it can be any combination, SN2, SN1, E1, E2. And then finally, for tertiary, it's going to be SN1 or E1 here, okay? And it says have that textbook, okay, okay. Yeah, so I got this from Klein, by the way. So yeah, guys, this is going to be our next example here. And cool, let's keep it going. Whoops, I didn't mean to go out of that. And guys, let's do another poll. Let's see how we're doing. Do we want to continue going with elimination, or do we want to switch gears here to another topic? So let's get that poll up ready. And there's only gonna be a few minutes left here for today, chat, but don't worry, I will be back tomorrow. Okay, so quick poll is active. So if you want to see more examples on addition reactions and synthesis, vote for happy face emoji. And if you want to switch gears to a different topic, vote for crying emoji and comment the topic that you want to see down below. Okay. Yeah, it's from David Klein's from the elimination chapter. I believe that's chapter 7. Okay, interesting. We're still getting more requests for more addition. Cool. So let's keep it going. So after you get comfortable with synthesis, let's see if we can find some good examples for retrosynthesis. Let's see if we can find some good examples for retrosynthesis. This is a quiz question about disulfide bonds for the Japanese hair straight. Oh wait, what happened here? This is a quiz question for that. Japanese. What reactions would be involved? I'm sorry, twin. I don't see your question. Life Angels? Did you drop your question? I don't see it. Okay, my exam is tomorrow. Can you go over some examples? SN1, SN2, E1, E2. Okay, so I'm getting a lot of requests for SN1, SN2, E1, E2. But let's see the poll real quick, guys. So guys, let's check the poll. Who cooked that up? So guys, we got 4 votes for still addition. So let me run that back one more time. So again, if you want to see more examples on addition reactions, okay, vote for happy face emoji. Let's run that back. If you want to switch gears, if you don't want to do addition reactions, for example, you want to do SN1, SN2, E1, E2, vote for crying emoji. Okay, let's run that back because I'm seeing like all of these. So I thought chemical engineers didn't know chemical reactions. What? Full synthesis pathways. Okay, so in the meantime, what's your name here? Wrangles? I don't see your question. There's a quiz question about disulfide bonds for the Japanese hair straight a permanent hair straight, what reactions would be involved? Um, do we have any more context other than that? I'm not sure. Okay, guys, let's check the poll. And guys, we're gonna be on for about 15 more minutes, so this is your last chance for today to ask your questions. And guys, we got equal votes, so guys, let's do a couple more addition, and then we're gonna end it for SN1, SN2. We got equal votes, so let's do a couple more examples for addition reactions, and then we'll end it for SN1, SN2. My question is if you know about the broken disulfide bonds from hair. Oh, okay, now it's going to be a little bit related to bio. Is treatment involving ammonia thioglycolate? Can you send me the problem? Can you DM me the problem and I'll take a look? Can you DM me the problem, twin, and then I'll take a look because I need to see what that be. But that does sound like it's going to be in the biochemistry context. Yeah, there's going to be some chemistry involved. There's going to be some biochemistry involved. Okay. And okay. And yeah, if you can send me that, twin, that would be fantastic. So guys, we're going to do this next reaction here is going to be basically our bromine going up just like that. Okay, and then this one is coming down just like that. Okay, so we have to identify, this is going to be our last addition reaction example. And then we're going to identify what is going to be, okay, we got to identify what is going to be the reagents here. And then we'll finish up with SN1, SN2, E1, E2. Okay, so guys, what do we add here? Okay, what do we add here? Can you explain the 8 reactions taking place in the Krebs cycle? Guys, I'm not really tutoring for biology. I can do chemistry and I can do like organic chemistry. Unfortunately, bio is not really within my scope. Okay, a reaction is taking place in the Krebs cycle, which is 3 steps of cell respiration. Yeah, unfortunately, I don't do bio, my friend. Okay, guys, so what do we have here is going to be, notice we have elimination here. So it's going to be a multi-step process here, right? So we basically have to have some sort of elimination here. And then we have our bromine that lives over here, and then our bromine that lives over here. But notice that this part of the substrate doesn't change. Okay, so what's the first thing we got to do? Okay, what's the first thing that we got to do? Cool. We got to make a double bond. Very good. All right, we got to make a double bond via elimination. Okay, so we got to do basically, thank you, Jackson. No you. So we got to do elimination here. And that's going to be basically forming an alkene bond over here. So from this first step, I'm going to add TBU, okay. I'm going to add TBU, okay. Okay. And then from this side, I'm going to add another set of what? How do I go from the alkene to the next product here, bromine here? First step is making the double bond on the first and second carbon. Last step is hydroboration oxidation. Cool. You're really close, but then I wonder if there's another way to get that here. So I was thinking that we're going to add HBr, okay, HBr, and then ROR, just like last time here. HBr, ROR. So that's going to be how we get from that side product here. Okay, so that's going to be our next example here. Add peroxide, so ROR. Okay, cool. So I think we're gonna call it here for today for addition, and then we're gonna finish up with SN2, SN1, E2, SN1, SN2. So let's get those. Oh, sorry, chat. Let me go back. Let me see if there's any questions here before moving on. We're gonna do our last topic for today is gonna be SN2, SN1, E1, E2. Okay, and then guys, don't worry if you want to keep doing this tomorrow. I will be back tomorrow to go through this again. Okay. All right, so we're gonna do one more. We're gonna do one more topic today, and then we're gonna go ahead and go down. Okay. Yes, ROOR is going to make it anti-Markovnikov. So we want to make that anti-Markovnikov. Okay. So the last topic for today is going to be SN1, SN2, E1, E2. We're going to see how many mechanisms we can squeeze in about 10 minutes. Actually, I got to do 5 minutes because I got to head out soon, guys. But again, don't worry, I will be back tomorrow. So guys, we're going to do SN2 here. So okay. So let's do our SN1 mechanism. Let's start with SN1. Okay. So SN1 is going to be a multi-step process. So we're going to have our loss of leaving group step. Okay. A loss of leaving groups here is step 1. Okay. Loss of leaving group. And we're going to generate, so that's going to generate a carbocation intermediate that lives right here. Okay. And then the second step is going to be our nucleophilic attack. Okay. That goes up to the final product. Okay. So our nucleophile is going to come in and attack just like that and attack this. Okay. So it's going to be our nucleophile just like that. Okay. So that's our SN1 mechanism. Of course. Yo, I'm definitely down to help you with buffers, but unfortunately we're doing OChem, not GenChem. Same for you, Gabe. We're not doing GenChem today. We gotta finish up with OChem. And so that, guys, this is our SN2. And no, that was SN1. So now let's do SN2. It's gonna be the same idea, was gonna be concerted process. So let's say I have our leaving group, and then we're gonna have our nucleophile. Okay, so our nucleophile is gonna come in, and basically, our nucleophile is gonna come in and attack, simultaneously kicking off that leaving group, and we're gonna generate that all in one step. Do you do physics at all? Of course. I'm lost on fields and potential differences and capacitors. Okay, of course, I got you on physics. Is nucleophile not N4? What do you mean by that? Is nucleophile not N4? What do you mean by that? So guys, I just want to get this real quick. This is our SN1. Just want to get that mechanism real quick. SN2. Here we go. So I'm just going to directly attack that. I'm just going to do a backside attack. Yep, I'm just going to do a backside attack here, and then loss of the leaving group. Okay. And then here we go. That's going to be our SN2 process. So I want to double check that real quick. And then guys, we're going to do 2 more, and then we're going to end it for today. We're going to do 2 more, and we're going to end it. Close our leaving group. Okay. This is going to be our leaving group minus here. Okay, so that's a real quick rundown of SN1, SN2, but where you have to really practice it. Okay, you have to really practice it. Yes, technically it's going to be backside attack. So technically I got to do it over here. Sorry, chat. Let's go back over here. It's going to be backside attack just like that. There we go. Okay. Okay. Guys, I'm getting more requests, but unfortunately I got to end it here. Okay, I got a request for SN1, SN2. So next time, if tomorrow, if you guys come back tomorrow at about 7 o'clock EST PST, come back tomorrow and we'll get the rest of those. But I gotta end it soon, so we're gonna do 2 more, and then I gotta end it. Okay. Okay. So guys, we gotta have SN2 doesn't happen on tertiary. So I mean that was just an example. That was just gonna be a general example. So guys, let me fix that. Yeah, let me fix that. What if I just make this secondary like that, just like that? Okay. So I'm gonna make that secondary just like that. 1, 2, 3, 1, 2, 3. Sorry, chat. My apologies. We gotta make sure that's secondary. Okay, there we go. Okay. So let's do E2 and then E1 and then we gotta call it. Okay, we're gonna do E2. Okay, so here's our base. And then here's our leaving group. Okay, so the base is gonna come in and attack this proton and then kick off this leaving group. So this is gonna generate the alkene. Okay, there we go. And then that's gonna be our E2 mechanism. Okay, and then last but not least, we gotta do one more, guys. We gotta do one more, and then I gotta end it. So unfortunately, whatever any other requests that you guys have, you can drop them in my you can drop them into Discord. You can drop them into Discord, and then we'll do them tomorrow. We'll do them tomorrow. So there's gonna be 1, 2, 3 leaving group. So we're gonna have loss of leaving group, loss of leaving group. We're gonna generate 1, 2 carbocation, and we're gonna do a proton transfer with our base, and gonna deprotonate this proton over here. Okay, deprotonate this proton. I'm getting messy here because running out of time here. Gotta hurry it up and generate our alkene just like that. Okay, so that was E1, E2. All right, guys. So I'm gonna basically end it here. I gotta basically end it here because I gotta head out. But don't worry, I will be back tomorrow. Hope this was helpful. Okay, I will be posting this on my YouTube channel tonight. So yeah, guys, if you want any more requests, you can just join the Discord link in bio. So tap that link that says engineeringminds.co. Okay, and then click on this link that says join the Discord. Okay, click on this link that says join the Discord. This is the best place for you to ask questions, interact with other members, and yeah, just interact with other STEM members, STEM lovers, engineers, and future doctors. Okay, thanks so much, guys. I will be back tomorrow. And make sure you sign up for tutoring by tapping this link that says book a free session. Okay, I can help you out with math, OChem, Gen Chem, physics, and engineering. And yeah, guys, website is 6. Shouts out Huel Academy, Huel Alchemy. Oh my gosh, I've been calling you Huel Academy. Yeah, building a STEMpire. And yeah, guys, last but not least, we're gonna have the Explore Resources tab. We're gonna start to add all the resources here for math, Gen Chem, OChem, physics. And yeah, guys, so thanks a lot for joining for today. Thank you, Jared. Appreciate you. So yeah, guys, pretty much gonna end it now. But yeah, once again, I will be posting this on my YouTube channel tonight, and I'll be back tomorrow around the same time, around 7 o'clock PST, or that's gonna be 10 o'clock EST. Thanks so much, everyone. Really appreciate y'all's support. I'll see y'all in the Discord. Okay, make sure you join in, introduce yourself. So I'll see you guys in there. Other than that, have a great rest of your evening, my friends, and good luck on all your exams. Okay, I'll see y'all tomorrow. Cheers, cheers. You already know that I don't do biochem, Jared. Lewis Dot, check my YouTube channel, twin. Landon, I got a video on that. I got a video on Lewis Dots. Check my YouTube channel. So go to my TikTok page, and then
Whoever
go to my YouTube channel. All right, I already have a video up on that. All right, peace out, my friends. Lewis Dot structures. Go down to Lewis Dots. It's right here.